Question 1 says equation x cubed minus 3x equals 34 has a solution between 1 and 5. Use trial improvement method to find this solution. Give your answer correct at one decimal place. Okay, so I know it's between 1 and 5, so I don't really need to test those. I'm going to try x equals 2 and see what I get. So I'm putting into my calculator, I'm going 2 cubed minus 3 times 2 and seeing what I get. So just do that on your calculator. So to use brackets and then 2, close your bracket and then cubed, and then do 3 and then bracket 2, close your bracket and press equals, and you should get 2. So you get 2. Our target, remember, was equal to 34. So what is this one? It is far too small. So I'm going to try 4 and see how that works for me. So I go back into, use my back button in the calculator, go back and delete the 2 and change that to 4. And that gives me, when you put that in, that gives me 52. And that is too big. So I'll try 3. Again, go in and delete the 4, change it to 3. And that gives me 18, which is too small. Okay, but because I've got these two things, that tells me my answer is somewhere between 3 and 4. It looks, okay, so I'm going to try 3.7. So I'm going to go in and change my 3 to 3.7. And when I do that, I get 39.553, which is still, oh, it is actually too big. I'll change that to too big. I'm going to try 3.6. So again, go and delete that. 3.7, change that to 3.6, and that gives me 35.856. That's still too big. It's getting closer. I'll try 3.5, and 3.5 gives me, when I put in 3.5, it gives me 32.375, which is too small. But I now know my answer is either 3.6 or 3.5. So you must test this thing. So test 3.55. So go in and delete your 3.5 to 3.55. Press equals, and that gives me 34.08875, which is just ever so slightly too big, but it's still too big. If 3.55 is too big, 3.6 would definitely be too big, so my answer is going to be equal to 3.5. So again, if 3.55 was too big, 3.6 would definitely be too big, so 3.5 is your answer, and that's to one decimal place. Question 2 says, when a spinner was spun 50 times, it landed on red 12 times. So after the first 50 spins, it's 12 out of 50, and 12 out of 50 on your calculator is going to be 0.24. It says when spun another 50 times, it lands another 9 times. So that's a total of 12 plus 9, which is 21 times out of 100, which is going to be 0.21. And that's it. Okay, it says when spun another 50 times, the spinner landed on red another 9 times. What value of relative frequency gives the best estimate for the probability of the spinner landing on red? So the third value, which would be another 9, is going to be 30 over 150, which is going to be work out to be 1/5, sorry, which is going to be 0.2. So that is 0.2, and that is because it has been spun the most times, so the most number of trials. Most number of trials, and that should get you the marks. It said the spinner landed on yellow 40 times in the first 100 spins. Estimate the probability of the spinner landing on yellow. So it is 40 out of 100. So that probability is just going to be 4 over 10, 4 over 10, or 2 over 5. It's probability. I prefer to leave it as fractions, but that's fine if you write it as 0.4. Estimate how many times the spinner will land on yellow in 300 spins. So in 300 spins, it's going to be 2 over 5 times 300. And then if you just do that out, whatever you're going to get, it's going to be 120. This question says a solid cone has a vertical height of 12 centimeters, so h is equal to 12, a slant height of 13, and a base radius of 5. Work out the total surface area of the cone. So for a cone, the surface area is a curved surface area, which is pi r(L), plus the base, which is pi r squared. So then you can just say that's going to be pi times my r, which is 5, times my L, which is 13, plus pi times my r, which is 5, and that was squared. So whatever that's going to work out to be, 65 pi plus 25 pi. 60 plus 20 is going to be 80, 5 plus 5 is 10, 80 plus 10 is going to be 90 pi, and that's all they want. Okay, it says the following linear inequalities represent a closed region. So you've got x plus y is greater than or equal to 3, 2y minus x is greater than or equal to 4, and y is less than or equal to 5. By drawing straight lines and shading through the regions on the grid below. Okay, so you've got x plus y is equal to 3 is a line you need to draw. You've also got 2y minus x is equal to 4 as a line, and y is equal to 5 is a line you need to draw. This one is easy. It is just a straight line, a horizontal line, and then these ones are going to be diagonal lines, so we'll do a wee bit of working out for them. So we had x plus y is equal to 3. To do that, put x equal to 0. You're going to have x equal to 0, and then y has to be 3. And also put y equal to 0, and you'll have 0, and then the x value has to be 3 for the other one. For this 2y minus x is equal to 4, we'll put x equal to 0, and then your y value is going to be 2y equals 4, which means y equals 2, and put y equal to 0, and you're going to have x equals minus 4. Now let's just check those points will go on our graph. They will. So I'm going to mark on 0, 3. So 0, 3 is here, and then 3, 0, that's my first line. So I'm going to pause the video and then draw that line. It's not easy to draw on this thing. Okay, so you can see my first line is x plus y equals 3. Okay, I'm going to draw my next line, which is 2y minus x is equal to 4, and it goes through 0, 2, and minus 4, 0. So I'll mark on 0, 2 first of all, and minus 4, 0. I'll pause the video and then draw that line on. Okay, you can see I've got this line drawn on now as well, and then my last line I have to draw is y equals 5. Y equals 5 will just be a horizontal line going through 5, and they were all greater than or equal to or less than or equal to, which meant they were all solid. I forgot to say that. So we'll just pause the video and draw my last horizontal line, and there you have it. There's my 3 lines drawn, and the question asked me to say, it says by drawing straight lines and shading through the region on the grid below, label the region R. So we want x plus y to be greater than or equal to 3. So that means we want above this thing. So by shading, I'm going to shade this bit here. I want this thing to be greater. Okay, that's a bit I don't want. And then I want 2y minus x to be greater than or equal to 4. So this is comparing this line, the 2y minus x equals 4. I want to be greater than. Okay, the easy way of doing this is rearrange this to make y the subject. So you have 2y minus x is equal to 4, and then we'll say 2y is equal to x plus 4, and then that means 2y is greater than or equal to x plus 4, and we could say then y is greater than or equal to x plus 4 over 2. Now if you get it in this form, if it's like 1y is greater than something, then you just want above the line. So wherever your line is, that's what you want. The region you want is above. Had it been a less than, then you would want below. So it's above, greater than, so it's above what the line is what we want. So we can shade this, the underside of your line. Okay, just like in the first one, we wanted x plus y to be greater than or equal to 3. So you could have rearranged, said y is greater than or equal to minus x plus 3, and we want above your line, so that's why, because of greater than, we want above the line, so that's why we shaded the underside. And the last one, we need to go up and look at it. It was y is less than or equal to 5, so again we want underneath this line, so then R is a region that we desire. Okay, the last part of this question says, hence work out the maximum value of 3x plus 2y in this region. Okay, it's going to be somewhere around the corners. So let's pick a few of the corner values. So there's a point there, there's a point here, and there's a point here, and we're going to try all of those. So let's look at the coordinates of them. The first one, the one on the left, the leftmost one there is -2, 5. And then we also have got, well, whatever that is, well, we don't even need to look at that. If you think about this one, here, it's got a smaller x value and a smaller y value than this one. So this is going to be my best value as long as it's in my region. So if I just find this one, that's going to be the best one. Okay, so this value up here, my x value is 6 and my y value is 5. So my x value is 6, my y value is 5, which means 3x plus 2y is going to be 3 times 6 plus 2 times 5, which is just going to be 18 plus 10, which is going to be 28. So that's going to be the best value I can get in this region. So we don't even have to work out this other one. So again, just go through that. This one has got a better x value and a better y value than this one or this one. So it's definitely going to be the best.
Okay, question 5 says, a book club offers 26 different books for sale, and it gives the prices of all the different books and the different options. It says Abby wants to buy 2 books for exactly £10, so she's only buying 2 books and for exactly £10. How many combination books can she choose from? Okay, there's only 2 ways she can really get 2 books for £10. She can get one for £3 and then the other one for £7. And there's 5 ways she can get a £3 book, and there's 8 ways she can get a £7 book. The other option, I'll do it in green here, she can get a £4 book and she can get a £6 book. So for it, there are 6 ways she can get a £4 book, and there are 7 ways she can get a £6 book. So if we work those out, 5 times 8 is 40, 6 times 7 is 42, so there will be a total of 82 different combinations.
Question 6 says, triangle R is reflected in the line y equals -1 and its image rotated 90 degrees clockwise about the point 1 minus 1. Draw the final image after these 2 transformations and label it x. Okay, you can see I've already drawn on my line y equals -1 to help me here, and I'm going to reflect first of all on the line y equals -1. So this is going to be reflected down, this triangle is going to be reflected down to here. Doing this without a ruler, and then it says, and it's rotated 90 degrees clockwise about the point 1 minus 1. So 1 minus 1 is here, so that's my center of rotation. So if I rotate this 90 degrees clockwise, so the direction the hands on the clock goes, so it's going to be going around this way. So if I rotate it around that way, it is going to go to that point. It's going to swing round. That point here is going to swing round to here. So that's where that one's going to go. I'm going to have a point here, and I'm going to have a point here. And that's where it is, and we're going to label this S. And describe fully a single transformation which maps R to S. So R back to S is going to be a reflection in the line y equals -x. Okay, so I'll just draw on y equals -x here to show you how that is. So if you have a look, that's one diagonal square from here takes me to here, and then another diagonal square takes me to here. A diagonal square and a half takes me to here, a diagonal square and a half takes me to here, and then two diagonal squares takes me to here, another 2 takes me to here. So you can see there's a reflection of the line y equals -x. Question 7 says one box contains 5 10p coins and 4 20p coins. One coin is taken at random from the box and not replaced. A second coin is taken at random from the box. Complete the tree diagram. So you've got 5 10p coins and 4 20p, so you've got a total of 9. So the chance of getting 5 at 10p is 5 out of 9. So 20p is 4 out of 9. If you've already taken a 10p out, you've only got 4 left out of 8, and likewise 4 out of 8 for this one. And if you've taken a 20p out, you've only got 3 left out of 8, so you've still got 5 left out of 8. What is probably that the 2 coins taken have the same value as each other? So same value means you're looking for the probability of getting a 10 and a 10, or So when you say or, you add, or you're getting the probability of a 20 and a 20. So a 10 and a 10 was 5 over 9. So let's scoot up here so we can see it. 5 over 9 times 4 over 8. Plus then a 20 and a 20 was 4 over 9 times 3 over 8. And then do that on your calculator and see what you get. And when you do that on your calculator, you get 4 over 9. The last part of the question says, what is the probability that at least 30p is taken? Okay, let's think about this branch, this tree diagram. This one is worth 20p. This one is 30p. This one is 30p, and this one is 40. So the only one that isn't 30p is the first one. So we're just doing, it's everything. It's 1 minus that first branch, which was a 10 and 10. So 1 minus 5 over 9 times 4 over 8, which is just being 1 minus, and whatever that's going to be, 20 over 72. And then if you do that out, 1 minus, and what have I just said, 20 over 72 is 13 over 18.
Question 8 says, a container of radioactive waste with an initial radioactivity of 100 is buried deep underground. It decays by 5% each year. After 2 years, its radioactivity A is given by the equation 100 times 0.95 to the power of T. Complete the following table and use it to draw the graph of A against T on the grid below. So there's you got your grid you've got to do. To do this, then, first of all, you're just putting in here to get the first one. It's just going to, A is going to be equal to 100 times 0.95 to the power of 0. And then every time you'll just change the power. So the second one's going to be 100 times 0.95 to the power of 5 as your t value changes to 5. Next one would be 100 times 0.95 to the power of 10, and so on. So just give those to 2 decimal places and see how we get on. Okay, so I'll just pause the video and do that. Okay, so I've worked those out. So 100, then 77.38, 59.87, 46.33, 35.85, 27.74, 21.46, and you can see I've plotted those as best I could on this. Okay, and so that should get me the 4 marks. Next thing it says, the half-life of radioactive substance is defined as the time taken for the radioactivity of the material to decay to half of its initial value. Use your graph to estimate the expected half-life of this container of radioactive waste. So if you remember, it said the initial amount of radioactivity was 100. That means you're going to go across at 50. So you're going to cross at 50 and down. And you should be using a ruler to do this. So if you go down from that, you will get very roughly, then that is going to be whatever that is, about 13 years. Okay, next question, nice easy one here, question 9. You're cubing. This really is a fact if you have A times B times C to the power of n, then it is A to the power of n, B to the power of n, and C to the power of n. So here you've got to do the 3 to the power of 3. You've got your A to the power of 5, it's raised to the power of 3. You've got your B to the minus 1, it's raised to the power of 3. So the numerical term, 3 to the power of 3 is just 3 times 3 times 3, 27. And then A to the power of 5 raised to the power of 3, you multiply. So it's going to be 15. Same for the B to the power of minus 1 raised to the power of 3. Multiply the powers and you'll get minus 3. And that is your answer. Okay, the next one. How you look at this one is important. I'm going to change how it's written. I'm going to write it as x to the power of half divided by x to the power of 3 over 2. And then I could write that as x to the power of a half minus 3 over 2. And then that is going to be x to the power of minus 2 over 2, which is the same as x to the minus 1. And I think that's what they would be looking for. I think that would give you your marks. Just to be sure, I would also put down that as my answer. So I'd say x to the minus 1, which is the same as 1 over x. And then you'll be guaranteed to get the marks. Okay, question 10 is a fairly tricky question. One of the harder ones on the paper. It said B is 30 kilometers east and 20 kilometers north of A. So it's 30 kilometers east and 20 kilometers north. And C is 40 kilometers from B, so that's 40 here. And then B is also 60 kilometers. C is 60 kilometers from A. Yep, and there we are. Okay, it says calculate the bearing of C from B. So what you're actually trying to do here, you're trying to find the bearing of C from B. So from B, you want to find the angle measured from the north, measure clockwise and all the way around. So that's what we're trying to do. Okay, so we'll bear that in mind. That's where we're trying to get to. So what we can do is we can split this triangle up, and we can use, well, trig first of all to find this angle. And we could find that angle straight off, but before that we're actually going to find, I think the best thing for us to do would be to find this side AB. So if we find this side, then we can use a cos rule to find this angle, and then we can use our trig inside to find this angle as well. Okay, first thing I'm going to do is find my side AB. So AB will be equal to, it's a hypotenuse, so it's going to be equal to 30 squared plus 20 squared, and then square root of all that. So if we just do that very, very quickly on a calculator just to make sure, that's 30 squared plus 20 squared, and that is equal to the square root of 1,300. That is perfect for my AB, so I'm going to label that as my AB as that now. That is the square root of 1,300. And now we're good to go. So all we need to do now is find this angle in here. I'll call this one theta, and then we'll call this one alpha, and then we have to find these two angles, and then we can find our bearing, remember. So it's going to be, this bit is going to be 180, and then the bearing is going to be 180 plus theta plus alpha. So we'll find those two things. Okay, cos of theta first of all, using your cos rule, is going to be equal to, cos theta is going to be equal to the root of 1,300 squared plus the 40 squared minus the 60 squared, all divided by 2 times the root of 1,300 times the 40. So I'm going to just work that out on my calculator very quickly here. Okay, so that works out to be minus 0.242681. There's a few more decimal places. I'll do cos to the minus 1 of that answer, and that gets me 104.0448 we'll go for. And then to find my alpha, so we're looking at this wee triangle in here. Look at this wee triangle. To find this alpha in here, I'm just going to write down SOHCAHTOA. And I've got my 30 is my opposite, my 20 is my adjacent, so I'm going to use tan of alpha is equal to my opposite over adjacent. So it is tan of alpha is equal to 30 over 20. So that means tan to the minus alpha is equal to tan to the minus 1 of 30 over 20. So whatever that works out to be, let's do that now. Tan to the minus 1 of 30 divided by 20. And that works out to be 56.3099. So that means my bearing, the last thing then, and remember what our bearing was, that's very hard to see. It was this whole angle all the way around from here, all the way around to here. So it's 180 plus theta plus alpha. We now know what theta and alpha are equal to. We've got them written down. So the bearing is equal to 180 plus 104.0448, and then plus the 56.3099, and we'll just do that very quickly, plus 104.0448 plus 180, which is equal to 340 degrees. So 340.35, let me see, does it tell me how to do this? How many degrees? I mean, what degree of accuracy? It doesn't. I would say that that's equal to that, and that is to 2 decimal places. Okay, so there's that question. I think that's probably the hardest question on the paper. Okay, and the last question, is this the last question? It is indeed. Okay, this is on direct and inverse proportion. It says, we'll read this bit here first, and we'll go back to the start. It says, which of the cases A, B, C, D, or E lead to each statement below? So the first one says, if x is halved, then y is also halved. And that would happen if two things are directly proportional to. So that would be y is equal to like kx, which is y is directly proportional. So that is A. Next one, if, so direct proportion, sorry, that's when one thing goes up, the other thing also goes up. One thing increases, the other also increases. So if one thing goes down, the other also goes down. Whereas inverse proportion, or indirectly proportional, then is when one thing goes up, the other goes down, and that's what's happening in the next one. So if x is halved, y is doubled. So that really is inverse proportion. So y equals k over x. And so that really is what's going on here, and that would be D. Y is indirectly proportional to. And then the last one, if x is halved, y is 4 times as large. So that would be y is equal to k over x squared. So that's going to be E. And the last one then, you could even do that one by process of elimination, by getting rid of the other ones. And that would be this, do the same thing as well. Right, the last one, it says, which of A, B, C, D, or E is represented by the sketch graph below? Right, this is clearly a wee bit of the y is equal to some number times the x squared graph. Remember your x squared graph, if you had it done both sides of the axes, that's what it looks like. So this is just one side of it. So it's y is equal to kx squared, and this means y is proportional to the square of x, or you could say y. So y is directly proportional to x squared. So it's this one here. So that is going to be B. And I think that is us done in this exam. It is the end of this question paper. So that is us finished.